So here we have some examples from problems from page 326, which is 5.1. And the first problem I'm doing is problem number 9. And so they say solve these systems by graphing. So the first thing I'm going to do is graph equation 1. And I'm going to label my equation. And here is equation 1. And since this is in standard form, I'm going to use my x and y intercepts. So if I let x equal 0, my y is negative 2. If I let y equal 0, my x would be negative 6. Then I'll come over to my graph and I will plot those points. So here is where x is 0, y is negative 2. Here is y is 0, x is negative 6. Those are my x and y intercepts. And I graph them and I label my equation. Then I'll take equation 2, and that's x minus 3y equals 0. So again, I'll look for my x, y intercepts, and what I notice is, my x and y intercepts, that's 0, 0. So I'm going to need to pick another point so that I can graph that line. So I just chose a point, and I put 3, 1, and I graphed that, and that gave me that point right there. Well, that didn't kind of tell me what was happening on this side of the graph. So I looked and I said, I think I'll try 1, 2, 3, negative 3. So when I put in a negative 3 here, negative 3 minus 3, I need negative 1 to make that equal to 0. So I went ahead and graphed that, and I noticed this is the point where they intersect, which is negative 3, negative 1. So that is the solution. I can check my answers by going and taking this point and plugging it back into both equations. So I stuck this point, negative 3, into equation 1. So where there was an x, I put negative 3 plus 3 times y was negative 1, and that does turn out to be negative 6, so I can check that's right. Look at equation 2. X was negative 3 minus 3 times y, which was negative 1, does equal 0, so check. It worked on both of those. So the next problem we'll look at is number 10. And number 10, my first equation says x minus y equals negative 4. So again, I found my x and y intercepts. To find my y intercept, I let x equal 0. That gave me 4 for y. If I found my x-intercept, I let y equal 0, and that gave me negative 4 for x. I went ahead and graphed that over here. There's 4 for y, and x is 0. Here is negative 4 for x, and y is 0. Connect the points and labeled it equation 1. Here's equation 2, x plus 2y equals negative 1. So again, I did my x and y intercepts, and what I notice here is that when I put x in for 0, I get a y-intercept of negative 1/2. And that's not very easy to graph when we have fractions. So I actually decided to pick another point so that I could see how to graph this equation. So I went ahead and I plotted those points. So here I was, that was, well, my 0, negative 1/2 is about there, and then I had 1, negative 1 was here, and I had my other points, and I plotted them. Then what I'm going to do is go ahead and go look and see, well, what happens when I graph these? And I notice that they intersect right here at negative 3, 1. So negative 3, 1 is my solution. I can check my answer here by going and sticking in negative 3 for my x and a 1 for my y. And when I do that, it does turn out to be negative 4, so that checked out okay. Here on equation 2, I'm going to stick in my negative 3 for my x and my 1 for my y. Solve that equation. It did turn out to be negative 1, so that checks as well. So my next equations, here we go, 3x minus 2y equals negative 6. This is number 11, by the way. Again, I'm going to use my x and y intercepts, so I have 0 and 3 and negative 2 and 0. So I come over here and I graph equation 1, and that graphed all nicely right there using my x and y intercepts. Here for equation 2, I'm going to do the same thing, x and y intercepts, and they gave me fractions. So then I go and I look at this and I say, hey, is there any other points that I can find that make it look easy, like it's not fractions? And I look at that and it's like, it doesn't look so easy. So I graphed it with the fractions just to kind of get a feel for what might happen. And what I notice is that it looks like they're parallel lines. And if they are parallel lines, then they don't intersect, so there's no solution. But I want to check to make sure that they really are parallel lines. And so what I can do is that I can rewrite these two lines. And so here I went ahead and I rewrote these two lines into slope-intercept form. And so here I'm going to move the 3x to the other side, then I'm going to divide everything over here by a 2, so I get y equals 3/2 x plus 3 for equation 1 when I rewrite it in slope-intercept form. For equation 2, I'm going to do the same thing, so I added 6x to both sides, divide everything on both sides by 4. When I do that, here again, I get 3/2 for my slope. And what I remember is when I have two equations that have the same slope, and we write them in slope-intercept form, if they have the same slope, that means that they are parallel lines and they do not intersect, so there is no solution. Here's another example, example 12, and what I see is equation 1. Again, I'm going to look for my x and y intercepts. For my y-intercept, x equals 0. For my x-intercept, y equals 0. There, I found them. I'm going to do the same thing over here. Oh, what I notice is that these have the same x and y intercepts. So when I go to graph them, what I see is these are exactly the same lines. One goes on top of the other. So I notice if the lines are the same line, then I have infinitely many solutions. What I also notice is that equation 2 really was just a multiple of negative 2 of equation 1. Next is number 14, and what I notice here, again, I'm going to start by finding my x and y intercepts. So when x is 0, y is negative 4. When y is 0, x is 4. That's all I need is 2 points to be able to graph that. So I come over here and I graph it, and this is equation 1. And then over here I come to equation 2, and I put in 0 for x, and I get negative 2/3 for y. So I say, yuck. I really don't want to use a fraction, so I'm going to try some other points. First I'll do the x-intercept, so I put 0 in for y, and I get negative 1. So I need to pick another point. I decided to just try 2 for x to see what was going on over here. So I put in 2 for x, and I got a negative 2 for y. I go ahead and I graph equation 2, and what I notice is that these two intersect right here. So the solution is 2, negative 2. I can go back and check my work by plugging those points back into the equation. So equation 1 is 2 minus negative 2. That does equal 4, so that checks out. Equation 2, right there, I just plug in x and y. So 2 times 2 plus 3 times negative 2 does equal negative 2, so that checks out. And finally, we'll look at problem 15. So 2x plus y equals negative 6. If I let x equals 0, I get negative 6 for y. If y equals 0, my x equals negative 3. This one, I will also find my x and y intercepts. I notice here my x was 0, my y is negative 1. When y is 0, my x was 1/3. And so that didn't really help me. So then I tried x is 1, and I got y was 2. And that told me what was going on this side, but it didn't really tell me what was going on this side of the graph for this equation. This was equation 2. And so what I wanted to do was say, well, what's happening on this side of the equation? So I chose let x equal negative 1 and see what happens. And when I did that, x was negative 1, then y was negative 4. And what I noticed is that that actually is the solution point. So my solution was negative 1, negative 4, because that's where the two equations intersect. I can go back and check my work by plugging it back into the original equation. So here's equation 1. I plugged in negative 1 and negative 4 for the x and the y, and it does turn out to equal negative 6. And then for equation 2, right there, I substituted negative 1, negative 4 in for the x and the y, solved that, and it did equal 1, so that checked out as well. So one thing to notice on these types of problems, it really helps if you have graph paper. If you don't have graph paper, it's very, very hard to figure out where they intersect.